All right, hello hackers and MX employees and MX hackers. So we're going to talk about Hackers Revenge, which I think most of you know is a game that we put together to run at conferences to lighten it up a little bit. We have a background at MX of putting together interesting puzzles for people to engage in. I think we've done like maybe 5 or 6 of these puzzles. And we thought it would be cool to do a puzzle for a conference, but we also thought it'd be cool to do a programming game. And I've written some programming games, I've played some programming games, and there are some pretty cool assembly language programming games out there, which is getting a little bit more niche from just regular programming games. And then we also wanted to make it a fun assembly programming language game, which seems to be maybe like a combination of oxymorons, but those of you who have played it can attest that there is an element of fun to it. So there is a history of programming games. I think the first one that I know about is a Cold War that goes back to about 1984. A.K. Dudney wrote this as a experiment for Scientific American. He had a recurring article in there about programming fun games and experiments. Cold War is still played today. People are super into it, but it's very complex. It wasn't something that we could have realistic expectations to have somebody learn within a conference setting with less than an hour to pick it up. So that was sort of one of the things we needed to think about. The other one out there is Archasm. This is the Nintendo game that I wrote for doing a assembly language programming game on a gamepad. I think I'm the only person that's ever played it. And I'm actually not even good at it. There's actually a 2-player mode and there's a versus computer mode. I've never beaten the computer. So, but it was fun to write. And then there's a game publisher called Zachtronics. Zachtronics has made, I think, 3 basically assembly language program games, but they're actually puzzle games and they're not competitive. You're not trying to defeat another program. They do have a sort of golf aspect to it where you're trying to write programs that are smaller or run faster than other people, but not sort of like a head-to-head. So for Hackers Revenge, one of the goals we wanted to have was to have basically, like I said, people compete. It was a competition. We wanted it to be fun. We wanted people to be able to pick it up easily for people who are not assembly language programmers. And I've told a couple of you, I think, that assembly programming at its core is not difficult. Hardware is difficult, but just moving things around and jumping and messing around with stacks is inherently not that tricky, unless I'm wrong. We wanted people to be able to code on their cell phones so they didn't have to pull out their laptops and stop what they were doing, so you could, thumb code. This may be actually the world's first mobile assembly language coding game, so we can add that to our awards, I guess. We wanted it to be visually appealing so that people who walked by our booth could see it and think, hey, what's that? And we're going to talk about this a little bit more later, but fairness. It's one thing to make a game, but it's actually hard to make a fair game where it's not, advantages for different strategies. That would make the game not fun. So what we ended up doing is we made the game stack-based because it made it easier to not have to worry about where you're going to be able to put data to make your program run. Every program that runs in Hackers Revenge has a private stack that they can manipulate. We put in a instruction called halt and catch fire. That's there to, it's almost like a mine or a bomb that kind of stops your opponent from running. And the kind of funny story about that is that it originally was called bomb, but some of our people who are smarter than us said, hey, if you're going to a conference, let's not use the word bomb. So we switched it to halt and catch fire. In order to keep it simple, we limited the instructions to just 15, so it was something that you could pick up fairly quickly. We kept the memory circular, so you didn't have to worry about running off the end, flat Earth kind of situation. It goes round. All the deaddressing is relative, so you're copying forward or backwards or looking forwards and backwards. So it's a little bit simpler here. There's only one data type. It's just positive, negative numbers. They are bounded when you enter the program, but they can get larger as your program runs. It was important for us to have a working mobile web UI, and I'll admit that I'm not a front-end developer. I did write the front-end code, and I had help from people who are front-end developers who knew how to make it suck less, essentially. And yeah, we do have some nice eye candy to make it attractive. It's fun to look at, and like I was saying, it's slightly addictive. People who like to play it really like to play it. Those of you've probably all seen this at this point. This is the mobile UI. Again, I'm not a JavaScript developer. We had someone from our marketing team drew a mock-up for me, and I copied the mock-up. He's really good at spacing and fonts and colors and things like that. My one was just gray, all different shades of gray. It's implemented as a canvas tag on JavaScript, and if you've done anything on canvas tag, it's a lot like a lot of game programming libraries out there, so it was sort of familiar to me in that aspect, and it was fun to write. Then the mobile UI, you can write your assembly code there with your thumb and manipulate the program by sort of moving it up and down. We added a test function so you can test out your programs before submitting them. And like I was saying earlier, in terms of fairness, Philip and I did a lot of back and forth. So there was like an initial idea that we had, but there were some holes in, like sometimes it was gonna be too easy to attack opponents. So we kind of scaled that back a little bit. Originally we had an instruction called attack, and you would say attack, and then you would give it an address, and it would drop one of the now non-existent bombs in that location. But we thought it actually made it just a little bit too easy, and it was just gonna become, I think, frustrating for people to play the game. So we decided to make that a little bit harder by you actually had to copy something from somewhere to somewhere else in order to corrupt another person's program. And we sort of envisioned from the start that programs would probably split into two camps of like style. Some programs would just sort of attempt to bomb in different locations to hope that they landed on an opponent. Whereas another strategy would want to be, I'm going to see if I can find an opponent faster than I can potentially randomly bomb that opponent. So we have the scan instruction. And originally what we were thinking about doing is having the scan run over multiple cycles, so that if you did decide to scan a larger location, you would have to wait longer for it to come back as a way of balancing out between that and attacking. But from testing, it seemed to be still a little bit too complicated, and programs that were able to bomb faster usually won out over that. So we replaced it with an instruction that can scan a large area, but it runs in one cycle, but it doesn't tell you exactly where what it found was found. It just tells you that it found something. So it was kind of a good trade-off between dropping just random bombs and trying to figure out where exactly they are. Which kind of brings in this concept of tempo. And I actually don't know if tempo is the right word, but it's sort of about how much of the board can you change or manipulate in a certain number of cycles. And so if you can bomb a large number of spaces in a small number of cycles, then I would consider it as like you have a fast tempo in your program. But if you're doing a small number of space in a longer number of cycles, that will be a slow tempo. So there are tricks that you can do within the language to increase your tempo. Same thing you can do with the scan, and that can give you an advantage of finding and destroying your opponent before they can destroy you. And then in terms of randomness, each time we pit two opponents together, we move them around into two random locations within the memory, because we realized that if the opponents were very close, sometimes a scan or a bomber would find them very quickly. But if they were further away, it would take longer, and another strategy might win because it found it first. So we had to kind of come up with the sweet spot of like, okay, how many times would we run a pair of programs together such that the differences would average out versus we don't want to take 10 years to run around. So through testing, we were able to get it down to about 20 seconds to run a full round by, I think we're at 6, we run each program as each operating 6 times with 4 rounds. So it does seem to average out. And one thing that we've noticed, and this happened actually yesterday, is that because when you submit a program, you battle every other program that's there. If someone submits a program that your program works better against, you can actually jump up and down the leaderboard without actually doing anything. So yesterday, we had someone who was in first place, someone who was in third place, and they actually swapped, I think, in the last 5 minutes because someone submitted a program that the third program was more effective about. So it does kind of keep people engaged because the conditions are constantly changing within the game. And part of the fairness, too, is that we were constantly trying to make it simplify the game, simplify it so people could learn it quicker. So we were having to take things out, put things back in, and it really was a matter of like, sometimes we simplified the game by making it less complex, and sometimes the the opposite happened. So, but I guess that's just the joy of iterative development. So Frontend is implemented, like I was saying, on the JavaScript canvas tag for the original thing, and like I said, I'm not a front-end developer. My JavaScript, I just used Bootstrap jQuery for jQuery mostly just for Ajax and Bootstrap because I hate CSS. So it kind of makes it easier to make things look nice. But my JavaScript actually looks more like Lua than JavaScript, so I didn't use a lot of different frameworks. Most of it's just plain old JavaScript. And yeah, I'm not a JavaScript. And Philip's going to go over the backend stuff for you, because that's what he did.
All right, thanks, John. My name's Philip, and I had so much fun creating this game with John. It was so fun every night to go home from work and tell my kids that I got to create a game all day, and it's not normally what I would work on. So what did we have to do first? Well, pretty early on, we're like, we need to prove out this concept to make sure that it's going to be fun, it's going to be fair, as John mentioned, and so we wanted to write a proof of concept. So what's the best language for proof of concept? Of course, we wrote a Ruby command line program, and that took under a day to write, and it was good because we could then start creating sample programs, and it was really fun at first to get into and be like, we came up with all these creative names like Head in Sand and Fortress and Fast Bomber, and we were just putting together these little programs and able to actually start running them and testing them and finding out, okay, is there really enough variety here that there's not just some real simple program that always wins, because obviously that wouldn't be fun. So helped us to get the sample programs, validate the concept, and a big one for me, I was a little bit worried about performance. Was I really going to need to optimize this and have the battles itself running in native code or something? But it turned out it only take 4 milliseconds to run a round, which has up to 2,000 cycles. So after I put together the POC, I knew, hey, this is not going to be a problem. We're going to just be able to do this whole thing in Ruby, and it'll fit within our time frame, no problem. And so the next thing that was fun about this proof of concept is actually was able to automate it. And so how do you automate a command line program if you don't use something like curses to move around and redraw the screen? Well, it's real simple. You print out every step of the way, then you size your font just the right size. Now you can page up, page down. So here's how we animate with page up and page down. So, voila. Hey, John, we didn't even need the front end. I mean, come on. All right. But yeah, this was fun and helped me to see, and I could see every single cycle and what was changing with the stack and everything. So that was the command line POC. Then I was ready to write the actual backend, and so what did we do? Ruby on Rails, of course. And I use Sidekick to run the match. And the match is the one that every time you submit, it does like a King of Hill competition. And so the contender against everyone in the top 10, you run like 6 battles, 4 rounds each. So that's, and the other person, so 6 times 2, 12 times 4, 48. Every person is against every other person for 48 rounds. Just had some SQLite databases with players, programs, instructions, battles, and rounds. I originally had a cycles table as well, but then I later took that out. I'll explain that in a minute. And so why did we choose Ruby on Rails? Because it's really fun, unlike C++. Sorry, C++ guys. This is coming from someone who did C++ for 20 years, and Ruby is way more fun. I'm sorry. It's just more fun. So what are some of the interesting lessons that we learned while doing this was we did a beta test at our company, let all of the MX employees try it out. And afterwards, John and I were looking at the scores and we're like, well, it was really weird because like 5th or 6th place had a score of 0, and like 7th and 8th and 9th, they were all like negative scores. And we decided nobody likes negative scores, so we just changed it. And so we did 200 points for win, 100 for a tie, 0 for a loss, instead of having negative points for losing. So that was one thing. Another was RubyConf and RSpec were very helpful. I wasn't sure at the beginning. I was like, well, it's a one-off program. Do I really need to worry about this? And, you know, I probably could have got away without it, but it was actually, I found it to be very helpful to plug both those in, though I admit I did disable like 20 different cops along the way. So sometimes every other commit was like, thank you, RubyConf, and the next commit was, I hate you, RubyConf, and so kind of went back and forth. I did kind of give up partway through on the specs. I didn't give up, but I was like, well, I'm close enough to the finish. I did specs for all the models, but these controllers are really small, and I don't really need specs. And then, of course, you know, I rationalized because it's just a one-off time that we're going to use it. Well, sure enough, this is now the 3rd conference we've taken this to, and we have had to make some tweaks. Well, one of the tweaks I made a few weeks ago actually broke the program submission controller, which if I'd had a spec for that, it would have easily caught that. So that goes to show that specs are good. Another interesting thing was Modulo. I wasn't even thinking about this, but when we wrap around memory space, of course, we need to, for our index, wrap around from like 255 to go back to 0, so just mod 256. But what I didn't think about was the opposite way. Well, what if you go negative? What's a negative number modulo 256? Well, every language does it differently. So luckily, Ruby happened to do exactly what we wanted. So -1 mod 256 equals 255. If you go to another language like C++, then it actually does more like pretend the negative's not there and do modulo, and then add the negative back on. So this would actually just give you a -1. So we wouldn't do what we want, so I was pleasantly surprised with Ruby. Another lesson was I needed to make it so that when you submit a program, that we didn't try to, like if 2 people submitted at once, we didn't want it to run this King of the Hill match, like try to do somehow 2 at once. Even if we could, it was, SQLite was giving database busy errors, and you know it's not really the best database language for handling concurrence with writes and stuff. So, but we didn't want that anyways. We just wanted 1 at a time and the rest to queue up. So how did I solve that? I just set the concurrency to 1, and then Sidekick only starts up 1 thread, and that was a real easy solution. I'm sure there's a better way, probably a different gem that you're supposed to use, but in our case, we only have 1 job type, which is run a match, and so there was really no harm in just changing Sidekick to just have only 1 thread. So now we ran into one of the first things I implemented was on the back end was a test round. So you could upload 2 programs and just output the result of how it worked. So all the cycles, up to 2,000 cycles. Well, if you'll remember earlier on in the POC, the round only took 4 milliseconds to run. Well, once I got to the real code, it was taking 750 milliseconds, almost a full second, to run just 1 round, just that one little competition. And that was too slow. That was not going to work. We would not be able to run enough rounds to make it fair. So I pulled out RB-Spy, which is something I've used in the past. It's a really nice profiler, and it's not intrusive. You can take any running program as long as it's MRI Ruby. It does not work with JRuby, unfortunately, but it will profile, essentially taking quick stack traces, basically. And it also has built-in to generate a flame graph. So when I ran RB-Spy, I quickly found the problem. Now, you see this little blue circle right here? That's how much time was actually spent actually running the programs against each other. Okay? All the rest of this was overhead. From here to here, see how it's run cycle? It does an add cycle, and then the little circle is actually running the program. All this overhead was this wasn't even saving the cycles to the database. It was just saving them to the collection, which was it's basically, with Rails, when you have a has-many relationship, you can access the dependency through that collection. You can add to it. Basically, it's like an array of active record objects. Well, all of this attribute assignment and attribute mutation tracker, I don't even know what all this is, but this is Rails keeping track of all of this fields in your active record or whatever. That was a major overhead. So, how do you fix when Rails is slow? Maybe there's other ways, but my solution was to get rid of it. So, I just changed cycle to be just a plain object with the fields that I needed to keep track of. The current position of where you're at, what was the result of which instruction ran, which address was written to. There's about half a dozen fields. And along with that, since it's no longer active record, I just don't even save it in the database. Turns out that because I'm able to speed it, after doing that, it sped it up from 750 milliseconds down to 25 milliseconds. Well, now when the front end says, hey, I want to see the results of this round so that I can do the replay, the fun animation, we still need that. Well, I just rerun the round like that. So I don't need to store anything. The front end asks for it, I just rerun the round. So for our particular use case, there was really no need to store all of those cycles at all. And then finally, later on, when I was implementing the match run, and that's the one that runs, so a match is the contender who submits, and then the top 10. Everyone competes against everyone with 6 battles with 4 rounds in each battle. So there's 2,640 rounds, and each round is up to 2 million cycles. So there's a potential of 5 million cycles. On average, maybe about 1 million cycles. If you think about it, you don't want to store every time someone submits a program. We don't want to store 1 million rows in our SQLite database. And we didn't need to. And that was, even with that fixed though, we were still taking 40 seconds to run 110 battles. So this was before I changed it later to do the 660 battles that you see here. Just 110 battles was taking 40 seconds. Well, it's because I still had this where the main problem was at the end of every battle, just saving the result. Well, I batched that instead. So I saved those up so that run all the battles. Okay, now save all the results together in a transaction. And also only save the last battle. Because for the replay, we really only go through and show one round. We don't even show all 4 rounds, just one round from each person. So we didn't even need to save all 110 battles, just the 11 battles, the last ones. So the moral of the story of both of these is stop saving stuff that you don't need to save. So some of you may have heard the acronym of YAGNI, which is you ain't gonna need it, and that's often applied to, like, don't write code just because you think you might need it in the future. That's a waste of time. Just remember YAGNI. So this is a similar concept of, okay, don't save stuff to the database that you don't really need to save. So that was one of the main lessons. And halt and catch fire. That's the ending slide.